Hello! This lesson is on the sandwich theorem, or the squeeze theorem, or the pinching theorem, whatever you want to call it. Okay. When we can't find the limit of a complex function directly, we can often find it indirectly. If we can trap or sandwich our target function between two simpler functions that have the exact same limit at a given point, then our target function must share that limit. So formally, the theorem states that suppose g of x is less than or equal to f of x, which is less than or equal to h of x, for all x in an open interval containing c. If the limit of the lower bound g of x and the upper bound h of x as x approaches c both equal a value L, then the limit of the squeeze function f of x as x approaches c must also be exactly L. Okay, let's look at a direct application with an example. So we are given an unknown function, u of x, bounded by two parabolas near x is equal to 0. We need to find the limit of u of x as x approaches 0. Okay, so first we have to evaluate the limit of the lower bound as x approaches 0. So when we substitute 0 in for x, it equals 1. Next, we evaluate the upper bound as x approaches 0. When we substitute 0 in for x, it also equals 1. Now, since the function u of x is sandwiched between them, the functions, then the limit of u of x as x approaches 0 must be 1. Now, the sandwich theorem is also very useful, very powerful for proving fundamental trigonometric limits. For instance, sine of theta is always bounded between negative absolute value of theta and positive absolute value of theta. Now, because both bounding functions approach 0 as theta approaches 0, then the limit of sine theta as theta approaches 0 is proven to be 0. And similarly, the function 1 minus cosine theta is trapped between 0 and the absolute value of theta. Since both bounds approach 0, the limit of 1 minus cosine theta is 0. This gives us the conclusion that the limit of the cosine theta as theta approaches 0 is 1. Pretty interesting, right? Okay, stay in school.